5th of May 1977, there was a movie released, Star Wars. And so basically, next month, it will be 47 years. That's a lot. That's more than I'm old. Okay, I'm close to that, I admit. But still, for that generation watching it in the cinema and many generations following, it came as a lot of inspiration because there is space travel, there is lightsaber fights, a lot of cool things in it that sparkle the imagination, right? And one of those things is the droids they are using in the movies, and this is something we'll speak about today. This is something we can build with technology we have. This is something you can build the technology that you have at home, and this is the way. So, let me take the clicker. Hello, my name is Goran Vuksic. First of all, I'm Star Wars fanatic. No one would guess, right? Originally from Croatia, I moved to Denmark 9 years ago, then 5 years ago across the bridge to Malmö, Sweden, where my wife found a job. Copenhagen and Malmö are connected with the bridge. It's 35 minutes commute. It's super simple, so I still work in Denmark. And my company, Synthetic AI Data, is actually registered there in Copenhagen. It's a small startup. I'll show you a bit what we do later on when we touch upon those things. You can find me on LinkedIn. I post about AI, IoT, some conferences where I usually speak. And as you can see, I have this MVP badge, Microsoft Most Valuable Professional. It is for AI because I'm often at the conferences sharing my knowledge on AI topics. I'm also one of the organizers of Azure Skåne meetup group. Skåne is south part of Sweden, so we have some cool meetups at least once a month in Malmö. Yeah, in short, that is me, tech guy who likes tech and been in this world for this time, like writing blog posts, doing a lot of cool stuff, and I hope you will find this thingy cool. Today we speak about Pit Droid. This is how it looks like. First appeared in 1999, film Star Wars Episode 1, Phantom Menace. Became, I would say, really popular, even though it doesn't have some fancy look. The thing is, with this droid, it is explained as designed as cheap and expandable droid, and main purpose is to maintain the podracers. We were also able to see them later on in Mandalorian series and so on. It is 1.19 meter high and has this ability, at least in the movie, that if you poke its nose, it will fold. Also, they say it was programmed with a sense of urgency, and their logical processors prevent them from completing the complex tasks. And this fact actually was something that triggered in my mind, okay, I want to build that one, but I want to make it smart. And that's how it started. One artist, Andre Wachel, created this 3D model. This is how the droid looks like, and it will also showcase this ability, right, folding down. That's how you see it in the movie when you tap its nose. I've been creating many different free time projects, mostly exploring some tech and things like that, and been creating some droids before. I mostly use Legos, but Legos are not great because they fall apart. Like if you push them a bit or there is some servo motor turning something around, it will quickly hit something else unplanned and it will crash. So somehow one day, actually on the Facebook, it popped up some group Droid division called, and there was a lot of users there. So I went to check it out, and this is a group of people that are creating STL files. Those are used to 3D print droids. And this Mr. Dave Moog is actually leading the group, and they are selling those files on Etsy for a small fee. And I think it's fine to pay that fee because many hours are invested in this, so those guys could have a beer at least. So if you purchase the files, don't share them around, point people there. And if you want to check out like what kind of droids are there, many different, you can see in Star Wars that you can 3D print, you can go to the Facebook page. And basically what I found in that Facebook page was this video. This is assembly of 3D printed droid. So droid is all pieces 3D printed, assembled, and in the end it looks like this. And I was like, wow, I want to do it myself. But first of all, I at that point didn't have the 3D printer. I bought it later and discovered it is a whole new level of stress because 3D printing is not fun actually. It's been around for some time, and maybe some of you tried it out, but it's not perfect. It can fail like really quickly. You need several hours for something to print, and when you print it out and like after 2-3 hours something fails, like it's not fun to restart and such. So I found in a group one nice Mr. Ermer, who is actually providing this service. He is also a Star Wars fan, and I reached out to him. He can be found as TD Outpost on Instagram. He is 3D printing those droids and selling to people like charge for a bit of work and material, and sends over the 3D printed pieces. So I decided to purchase that package and to start this journey. First of all, the head. First thing that came into my mind, there are some LEDs, diodes over here providing the light. I had this idea that I need to fit some things in the head, and I wanted to make sure this will work, right? First of all, there is one small Arduino switch, then camera. Camera will go inside of the head over here in front, so droid can have vision. There are two digital servo motors that go in hand, so one moving head horizontally, the other vertically, and there is NVIDIA Jetson Orin Nano. Small computer, small board that is actually powering this droid and processing the video from the camera, controlling motors, and so on. You will see that soon, but to show you how the process went, first of all, when you have 3D parts, they are not perfect. The more expensive printer you buy, they will look better, but still it requires some sanding because you want it to be the smooth surface, and you want paint to stick better to the pieces. So you need to do it either manually, you can try that and give up after a few hours, same as I did. Then you buy a machine and start polishing it, and then, okay, finally it looks okay. You need to wear the protection for the reason because this is super small plastic pieces that you don't want to breathe in and such, and can make a huge mess. So do it outside. That's me on my balcony. After that, the painting process. Yeah, that is takes few iterative steps. First, you need to apply the base to those plastic pieces, then apply paint, then let it dry. If you are living in Sweden and doing this in the I think it was March last year or something like that. Basically, you don't have sun to dry it, and I was doing it in a basement. And a few days later, I had to explain my landlord that I will clean all the floor and mess that I did in front of my basement, also not just inside. But okay, repeating this process, having fun, you start to assemble it. It's also painted in 2 colors, so that takes a bit more time. So when things start to get a look, it becomes more fun, and you are always enthusiastic. Let's paint some more and connect some more. So first the legs, then the body, and yeah, torso of the droid, connecting the hands, and preparing the head. And this is what I got in the end. Here you can see some wires sticking out of the head. This is one of the first tests I did. You can also notice there is camera here already installed. LEDs are on, so they are powered. There is this small computer in the head and servo motors. So when I turned it on, this is what I got. Cool, it's moving. Now we can start with the fun part, right? So basically it was the hello world thingy, like I managed to build my robot, and while doing that, I was writing the post on Huckster. You can find me there. All my projects are there, with source code, with full explanation how something was built, connected, and things like that. So in the end, when it was ready, I published this blog post, NVIDIA Jetson Orin Nano powered Pit Droid. It got featured by Huckster, and a few days later, NVIDIA called also to make an interview with me, the maker behind the droid. So 2 articles about it, and I was featured twice. I was super happy about that thing. I presented it several times on conferences. I was here in Utrecht last year on Azure Lowlands. I don't know if anyone was there. Droid was with me on the stage, but I decided not to carry it today or to some future conferences, and there are specific reasons to it. I'll show you a few pictures so you'll understand what I think about bringing Droid to the conference. First of all, you need to pack it in the travel bag, right? I need to fly. So you can imagine me standing there at the security at the airport. As soon as you remove this, there is a lot of wires hanging out, and you need to explain. Like, I believe those security guards, they're not like electronics experts and don't know what the Jetson is, or Raspberry Pi, or Arduino switch. There's a lot of wires there. So if you see the guy, long hair, tattoos, like at the security over the bag with a lot of wires sweating there, maybe it's Star Wars fanatic, not some terrorist, right? So, but yeah, somehow that is explained with a lot of internet pictures and things like that. And then you travel to the hotel and you need to assemble it there. The thing is, screwdriver is considered a weapon. You cannot carry that on the plane. So first thing you need to do, you need to run around and buy screwdrivers somewhere. Of course, some of them will not fit, and you'll spend a lot of time putting this together and such. And you also figure at some point, like, pliers could be a nice thing. And going to reception and explaining to lady, like, yes, I need pliers. Like, no, we don't have it in a hotel. Not even Jedi mind tricks worked, And yeah, you need to improvise. Not quite fun, but at some point, like, you start assembling that and connecting it together. And at one point, there is this moment of fun. This is Sherry. She's a co-founder in my startup. We often do some sessions together. And as we know, moments of fun don't last long. So you could end up maybe figuring out that it's not connecting to the hotel Wi-Fi. So you spend night like this, assembling everything. And also transport to the conference can be fun. Not everybody is thrilled to see the robot, and you know, small things like uh, carrying it in a taxi and stuff like that. But at the end, we were there at stage, Pit Droid sitting in a chair, like it was achievement, and definitely something I would not repeat. So sorry it's not here, but you'll see a lot of pictures and videos, and figure out how this is working. So let's get back to assembly, to the droid's brain. We'll focus some time over there. We said there is a small computer inside. There could be several options, but two most obvious is that you use something like Raspberry Pi. Raspberry Pi is tiny desktop computer. Price Model 4 is from $35. Not sure how much Model 5 is at the moment, but it is super cheap and like easy option to connect things to it. Like you have standard ports down there. There are some pins where you can connect motors, LEDs, and things like that. More advanced option or more expensive option is to go with some AI, edge AI computing device, such as NVIDIA Jetson Orin Nano. Developer kit costs like $500. They call it Jetson Nano Raspberry Pi on steroids for the reason like of its power. It's capable of processing the AI model here on the device. So you can spin your model here. With the Raspberry Pi, you need to take your data to the cloud, process there, call some API, return the result back, and perform the action. So if you want your robot, for example, to recognize some object, let's say I was doing that with R2D2. You place the R2D2 in front and then take a picture, send to the cloud, analyze where is R2D2 in the picture, returns the value, and then position the head toward that object. The thing is, with this device, you can spin model here at the edge and perform everything basically in the real time. Making a closer look at this NVIDIA device, like first of all, under the cooler here, one thing also, there is a cheaper version. There is like 4 or 5 years ago, there was Jetson Nano, which has a passive cooler. That's around 100 US. Might be an option that can also spin the models at the edge, but the thing with passive cooler is heating a lot, and you are using 3D printed plastic, right? So you don't maybe want to combine that. It's better to go for the active cooler. You need to flash your OS on the microSD card and put it beneath the cooler. Down there, there's one small slot. Then you can see, same as I showed you on the Raspberry Pi, there is this 40-pin header over there where you can connect different things like motors and such, control them. Power indicator LED, something's blinking, green, yes, it works. There is a USB-C port, there is Ethernet port, so you can connect the network or you can connect it to the Wi-Fi. There are USB ports where you can connect the mouse, keyboard. Display port, this is the power, and small camera connectors. Camera, the one I was using is USB. Connecting it to USB port, but if you've seen the small cameras from Raspberry Pi, you can also connect 2 of them. So you can build something with stereo vision if you are after something like that. Pin layout, nothing to worry about. It will not become complicated. Whole presentation is pretty easy, but just to give you enough of info if you want to go into something like that. Basically, 4 different things between those pins. Red ones 5 volts, yellow 3.3 volts, right? We know that we need to connect something to power and to ground to work. And eventually we will have a 3rd pin, which is a control pin that is sending some information. Okay, turn it on, turn it off, right? So it's always connected to power. In some combination, depends how, depends what you need, and sending signal to it. Such example is that Arduino relay. We want to be able to turn the LEDs on and off. And first we need to connect the relay. We connect it to the power and ground, right? And then we have this yellow one, which is sending this control signal. Okay, turn it on, turn it off. And when it says turn it off, turn it on, connects that circuit there with batteries and turns on the LEDs. Pretty simple. And this is how it looks in a code. If you want to do it programmatically, like you need to import this this is example from the Raspberry Pi. AirPi.gpio, general purpose input output library. We will be using time. We need to set the mode and our which pin we are using for the control, where are we sending this signal to, right? And then we want to turn the LED on. We just say, okay, send me output 1, and it turns on the switch. And if we say send me output 0, then it will turn it off. Pretty simple to work with this, like only few lines of code. Similar thing with servo motors, also controlled with we have power ground and control pin. The ones used in this are 25 kilos and they are used for, as I said, head movements. One is controlling up and down, the other one is controlling left and right. Very similar code, output pin that we are controlling, and then we are sending this command to start, and then we are moving head in specific direction with this change duty cycle. Yes?
What's the 25 kilos mean?
That it's capable to move 25 kilograms. It's not that heavy. It's super small actually and super light, but that's the strength. At least they say. Yeah, never tested with that. Seems heavy for such a small motor, but fine. And yeah, as I showed you, assembling motors. So we have our computer in assembling motors, assembling LED. We are able to do exactly this. We are able to control the head, move it in the direction that we want, and we can turn on the LEDs. In the head, there is this webcam. Super simple, cheapest one, I think, that I was able to find in a local store. The thing that was important for me, that it works on USB, that it's plug and play. And resolution was not so important. It's just this is completely sufficient. So I can place it in the head and then can give my robot sight. So placing some object in front, I can recognize that object and move the head toward that. So now going a bit to Azure topic, like how Azure can help us out with things like this. We want to make our robot smart. We want to make our robot understand voice commands. We want to make our robot speak or something like that. There is a great thing released last year. It's called Azure AI Studio. I think it was in July, if I remember correctly. Came to the market, and this Azure AI Studio is like provides unified experience for AI developers and data scientists. It is a nice web UI where you can, in one place, build, evaluate, deploy AI models through a web portal. There is also SDK and CLI. In order to access AI Studio, you can go to ai.azure.com and some page like this will appear. You will see this hub, and under this hub there are many different ones. I'll show you how project is created in this hub, what we can do with it, and then it's up to you to explore this further. Check out documentation, check out the tutorial videos. There are some nice videos from SET, like you can figure it out. It is not, you don't have to be like hardcore data scientist or hardcore AI developer to use this. It's just clicking through the interface, and Azure is doing a job for you. First of all, we want to create the AI project. Before we create the AI project, we need to create, we'll enter the values for the project, and we also need to create our hub. So here, pop-up will appear asking us about project name and asking us where do we want to place this, which resource group, resource. And we will create this AI Hub resource, select our subscription, resource group, select location. Here at the moment, you probably don't see it, and I'm sorry, the screen is a bit small. Here it's written Sweden Central. Depends where you are. You need to check which services are available. For majority of services, you will have to pick East US, but this is of course expanding every day, and it's documented there in you can check documentation, or after you create the hub and try to create something that's not available, it will give you a message, so you'll have to go a bit back. So we are creating a hub. Quick review. We say create our AI project, and we will see this pop-up. What is actually created for us? Like, it's creating AI project, AI hub, our storage account, key vault, application insights, and log analytics. So basically just with a few clicks. Otherwise you would have to go back. Before we didn't have this. You would need to go to portal, create resource group, create all those elements inside of it. Right, and then we enter our studio. Once it's finished, it will look like this. This is where we land. If you check the portal, you will see exactly that. Azure created all those resources for you. So this is sorted out. For the studio, great thing is there is a huge model catalog, and Microsoft is expanding this like every day, adding a lot of different models there. You can see models not just from Microsoft, but also from Meta, Hugging Face, NVIDIA, and so on. Like really a lot of models that you can try out, select, okay, I want to use this model, test it out, deploy it in my own environment, and see what I can build with it. For example, like in this model catalog, I'm selecting Auto ML, doing the image segmentation, trying to figure out what's in the image. Whichever model I pick, I get a really nice page of description with also the examples. Okay, how training data looks like. For example, for the images, I'll also get examples how the results look like. There will be some sample JSONs, what we need to send the response, and so on. So I select the model I'm interested in. Here on the bar, there is a small button deploy. I click that and I get several, could be one or several options. Usually I want to deploy the real-time endpoint. When I click that, I get few options to select how I want to deploy it. I need to boot the virtual machine. It's offering me how many instances you want, automatically trying to sell me 3 because that's recommended. I put it to 1. You select the machine you want. This one is 1.07 US dollars per hour. Just few clicks, click, deploy, and you get to this screen where there is some state updating, something is happening, and after some time you get a check mark and you can try out your model. Here in the Azure AI Studio, this is a details overview, right? We can also go there, test our model, consume it, where we get endpoint. This is the endpoint we deployed. Here's the key. And here we get code. We can immediately copy paste. We just need to change the endpoint. We also get the examples of body, what I need to send, what kind of data, and what it will return back. Examples in JavaScript, Python, C#, R. So use what you like. Or examples are pretty simple if you want to use something else to write it there. And as I said, this Azure AI Studio is the top hub. And in top right corner, you can see this small drop down here that gives you many other studios. So there is OpenAI Studio, Azure Machine Learning Studio, Language Studio, Speech Studio. Maybe you want to speak with your droid, right? You want to give it some command like Alexa or Google Mini, use it that way, like move head, left, move head, right. Something you can do with the speech. Vision, where you can develop things regarding the computer vision, and so on. We spoke about camera, so that's why I'm focusing on the robot vision, how to make it look, understand the world around it. With computer vision services in Azure, we are able to do image analysis. Basically, what comes out of the box, you can detect up to 10,000 different objects. Show it an apple, show it a banana, right? Perform some different actions on input. Spatial analysis, I'll show example of that, basically understanding the space and things that happen in space. Some other things still fun to mention. OCR, we take it for granted today, right? But took us a lot of years to actually get it work and to be able to recognize handwriting and things like that. And there is also facial recognition. And this is how image analysis on the Google works. It can detect specific objects in the picture, but it can also give you the description of that picture. This is called multimodal approach, where we have a vision model figuring out what is in that picture, cows, and then some language model giving us reply, okay, those are cows grazing in the field. Pretty cool to play with it. I said spatial analysis, like detect when, for example, people enter or exit the zone, right? We can mark on some area, like we don't want people here, and detect is there someone in that area. This is actually, like in a real life, this is used for, you could use it for security reasons, like in the manufacturing industry, there are some dangerous areas around the machines. You don't want people to go there, so maybe detect that and raise the flag. Or in the retail, in the store, count the numbers people standing in the line, and so on. Vision Studio, pretty simple to use. As soon as you turn it on, gives you a lot of those examples, like what you want to do. I want to extract text, I want to extract images, this and that. Great thing to start and to work with and to use from your droid. Basically, you get some endpoint where you take a picture, send it there, analyze, and perform some action. Turn on motor, turn on LEDs, or whatever you connect. You can connect many other devices. Quick demo, just what I was actually doing with this vision thingy. So I wanted to, okay, how we do this? Like this. This will be tricky to navigate. Okay, so I wanted Droid to recognize R2D2. There are no models trained to recognize R2D2. Not sure which object it recognizes, maybe robot, but not sure. So what I used is the custom vision, trained it like over here is some 1,000 images. This is actually what my startup company does. We have a solution that is generating synthetic images. Those are simulations, like this is Lego R2D2, the small minifigure. We generate a lot of those images that are automatically annotated. Whichever picture, sorry, this is really hard to click around. Whichever picture I open, like there is object that is automatically annotated, right? If you use the real pictures, you need to take a lot of pictures, upload them, and then go into each picture and manually annotate it. We have a software solution that is doing this for you, like rendering object in different environments and then automatically tagging to speed up the whole process. So once you train your model over here, you can start using it by clicking here quick test. Basically, what will quick test open is like you can send some images to it, right, and detect, okay, this is our R2D2. And for the model, you can also publish this model and get the endpoint where you actually access it. So you take a picture, send over there to this endpoint and try it out. That way your droid gets the sight, and then it's up to you, up to your imagination, how you want to use that, what you want to do with it, and things like that. A bit about a bit about some of my future free time plans. Like what's next? I built Pit Droid. It's great, it's out there, but I'm building something else at the moment, and hopefully maybe in a year or so I'll be back on a stage somewhere showcasing how that was built. I don't know, have you seen the NVIDIA GTC conference? It's one of the biggest conferences, and Mr. Jensen was presenting this cute Disney droids in his keynote speech. The thing with Disney, we don't really like them. They purchased the Star Wars like 2012 and started like bit shifting that movies from what they were, and they have unlimited resources. They can build whatever. A few years back, they built a lightsaber, realistic lightsaber that is unfolding. So they press a button and woo, amazing. And they said, yeah, but this is for just showing, not for sale. You cannot get that. That is for our actors. And everybody was like, yeah, thanks for show off. So anyway, they also build these small droids that are walking around and doing great stuff. They are funny, call them ducklings. And they are in the Disney World and will entertain people over there. So guess what's community out there is doing? I guess I'll play my little role in this also, like immediately as it was announced by Disney. Some sketches started and things like that, but I'm not alone. There are 1,000 people out there sharing what they prepared, how they developed some things and things like that. 3D files are already available on some of those groups I'm following, so you can 3D print it to look like that. It's running actually on 2 NVIDIA Jetson devices inside. So far, community is building it on one, training it really to walk around. I spent some time on a logic like figuring out, okay, how would I solve interaction with this droid in a bit better way than I did with the Pit Droid. So over here, I'm turning it on, right? Here is a small light. So I say light on, recognizing my head to turn it on or off. And then I say, okay, look at me, waiting for command, and then detecting my finger to move in the specific direction. So projects like this are a lot of fun. And I really hope that this session at least sparkled a bit of imagination and yeah, gave you insights like how easy it is to build this, because it's just a few wires there, one small computer, camera, 2 motors, and that's how it is. So I would say thank you, and may the force be with you. We have like 3 minutes or something like that left. If someone has a question, please shoot. Yes?
Did the Pit Droid eventually really see and react to its camera?
Yeah, so I'm using NVIDIA Jetson Orin. It's detecting real-time processing on the board, and I did some things that it's detecting me and following me as I move around. What we also did that was pretty fun, there is one company called Neurosity. I showed my co-founder Sherry. When we were demoing it, Neurosity has this gadget that you put on your head, and it's detecting your thoughts. So like it can you can train it to detect specific thought. It's a pretty complicated process. You can check it out, but it really can trigger, like you can thinking about something like I'm eating a lemon or something. If you train it for that, you can turn the droid on, and then also with movements of the head you can control it like that. There's a lot of options you can do with this, and pretty simple interface, like yeah. Yeah.
What about walking? What are you planning to do?
That is, yeah, that is another level of fun, and with duckling should be much simpler. Like Pit Droid is too tall and like this tall, right? So it's kind of hard to make it walk. So I've seen some people adding servo motors and to the hands and moving the hands. But yeah, a bit tricky for walking, but definitely possible for the duckling, because it's closer to the ground, short legs, and then easier to simulate that. Yeah. Any more? If not, thank you again, and enjoy the rest of Future Tech.